Kotlin Delegation. Learn how to use the by keyword for lazy initialization, observable properties, vetoable validation, map delegation, custom delegates, and class delegation. These patterns reduce boilerplate and make your code cleaner. Let's dive into delegation. Imagine you have a property that is expensive to compute. Maybe it connects to a database or loads a large file. You don't want to compute it when the object is created. You only want to compute it when someone actually accesses it for the first time. That's exactly what lazy initialization does. The byLazy block creates a property that computes its value only once. The first time you access the property, the Lambda runs, and the result is cached. Every access after that returns the same cached value. No repeated computation. This is useful for database connections and expensive calculations. By default, Lazy is thread-safe. It uses synchronization, so only one thread computes the value, even with concurrent access. If you know the property will only be accessed from a single thread, you can use Lazy Thread Safety Mode, none for better performance. Choose the right mode for your use case. Delegates. Observable fires a callback every time a property value changes. You receive the old value and the new value. This is perfect for logging changes, updating the UI when data changes, or syncing state between components. The callback has 3 parameters: the property reference, old value, and new value. Here is a user settings class using observable delegates. When you change the theme property from light to dark, the callback prints the change. When you change font size from 14 to 18, it prints that change too. Every assignment triggers the callback automatically. No manual notification code needed. Delegates. Vetoable is like observable, but it fires before the change happens. Your callback returns true to accept the change or false to reject it. If you return false, the property keeps its old value. This is perfect for validation rules like preventing negative health or ensuring scores only increase. Look at this player class. Health uses vetoable to reject values below 0. Score uses vetoable to reject decreases. Name rejects blank strings. When you try to set health to -10, the callback returns false and health stays at its previous value. The invalid assignment is silently ignored. Map delegation lets you delegate properties to a map. The property name becomes the map key. When you read the property, Kotlin looks up the key in the map. This is useful for parsing JSON data, configuration files, or any key value structure. Use map for read-only and mutable map for read-write. In this example, user from map takes a map and delegates name, age, and email to it. The property name matches the map key. When you access user.name, Kotlin calls map.get with the key name. With a mutable map, changing config.host also updates the underlying map. They share the same data. You can create your own delegates by implementing read-write property. You need 2 methods, getValue and setValue. The getValue method returns the current value. The setValue method receives the new value and decides how to store it. This gives you full control over property access. Here is a trim string delegate that automatically trims whitespace. When you assign a string with spaces around it, the setValue method calls trim before storing. A clamped delegate keeps values within a range using coerce_in. These custom delegates encapsulate reusable property logic. A log property delegate logs every read and write. When you read the property, getValue prints the current value. When you write, setValue prints the old and new values. This is useful for debugging. You can attach logging behavior to any property without changing the class that uses it. Now let's look at class delegation. This is different from property delegation. Class delegation lets a class delegate an entire interface implementation to another object. The compiler generates all the forwarding methods for you. You use the by keyword after the interface name in the class declaration. Here we have a logger interface with log and error methods. Console logger implements it. The service class takes a logger parameter and delegates the logger interface to it using by logger. Now service can call log an error directly without writing override methods. The compiler handles the forwarding. You can still override specific methods while delegating the rest. In this prefixed logger class, we override the log method to add a custom prefix, but the error method is still delegated to the original logger. This gives you selective customization. Override what you need, delegate the rest. A class can delegate multiple interfaces at the same time. This cache service delegates both logger and cache interfaces to different objects. It can call log from the logger delegate and get input from the cache delegate. This is composition over inheritance. You combine behaviors without deep class hierarchies. Without delegation, you must write override methods for every interface method manually. If logger had 10 methods, you would write 10 forwarding methods. With delegation, you write 0. The compiler generates all of them. This eliminates boilerplate and keeps your code focused on the actual business logic. Let's compare all 6 delegation types. Lazy computes a value once and caches it. Observable notifies you when values change. Vetoable lets you reject invalid changes. Map delegation reads properties from a map. Custom delegates add any logic to property access. Class delegation forwards interface calls automatically. If you like this video, hit the like button and subscribe for more tutorials.